So we are continuing from where we stopped last time now. We look at a multiple linear regression last time. So this is just a complete completion or continuation of that part of a multiple linear regression. So this time around, we want to look at a multiple how to visualize our relationships in multiple linear regression. Don't forget we are talking about multiple predictors this time around, and comparing with a previous one, which is a single predictor. So we want to use different methods to see how we can visualize the relationship between our predictors and our target variable. So the first method we are going to be looking at is called partial regression plots. And this is to visualize how each advertising channels related to sales. Don't forget, sales our target variable while accounting for the other variables. So we use partial regression plots, which also called added variable plots. This show the relationship between each predictor and the target after controlling for other features. All right. So if you run this line of code down where we are recording our start models.api now this time around, so we have not been using that before. Then that's one of the that's what's different from others we have been using since. So we have not been using this before. So we want to use this particular one to fit our model for diagnosis purpose. Right, so that will diagnose the scale and give us a proper fit. Okay, so if I run this line of code now, other ones seem similar because we are using one to standardize, right? Which we have done before. That's a scale. Then we fit in the model using our start models API. Then we create our partial regression fit here, plot here. So I think it's too big. I can make it smaller. Okay, let's leave it for now. If you need anything, I can reduce it later. So let's run this line of code and see what we have here. So we see loading. So we have it now. So now we can see each of them. We have YouTube versus sales, controlling for others, which means controlling for Facebook and newspaper. So we also have Facebook versus sales. Okay, we also have newspaper versus sales. So you can see their trend here. You can see their trend. You can see their trend. You can see the newspaper very poor. See this. So this is how we just use this one to visualize them. I mean individually, right? Then you can also see. I'm going to explain this structure of this particular figure because it seems some of us do not understand the concept of plotting in Python. It's very simple. I will explain as we continue gradually now. So now you can see here. Each plot here display the unique contribution of one predictor after accounting for the others. Also, the slope matches the regression coefficient from our multiple regression, and the point further from the lines are observations that the model struggle to explain. Every point that is further from the line is technically called the outliers, which means the models struggle to explain them. Anyone those that are close to the line, they are the one that our predictors, which the model can explain properly. So you can see a lot of points far from the line, right? So we have more 0.5 from the line from this second one, which means that this one the model struggle to explain these ones, and most probably here also you can see them very far from the outline. So that is that for that. Then let's move on quickly. Let me explain this plot as it is now. So let me break down the plot here. If you check the code here, we have here our figure is equals to we call our PLT figure here to plot this function to make it 15 by, because why is that I want to make it bigger, because I want to have a long row and a column, because it's going to be long 3 by 1, right? So but this one need to be big in length like this, it need to be short like this, so I can make it reduce it also to 10 by 3. It will be fine as well, but just for you to see clearly what I have here, that's why I did that. So if I change this one to 10 by 3 for example, 10 by 3, I run the code, it will be smaller, but at least you can still see it. You can see it's very small. Yeah, because I didn't change this size up here, this one, I didn't change the label, this label size. I can have their size separately. So, but let me just return it back to let me 12, 12, 5, 12, 4. Yeah, that would be a little bit better. That one's better now. Okay. So if I don't want it to be too big and at the same time not to be too small that you can see. Now, what I'm trying to explain now is this particular plot structure, how it is now. If you see this, if you see here now, you can see we have 131. Okay, so this for YouTube now, for each of them, we have 131. Before we cut our the graphics plot part 3 to plot our business out. This is just a title. Here we have 132. Here we have 133. Right. So for those who are new to Python plotting, I'm just trying to explain this once and for all so that I will explain it next time. So if you look at this my structure here, this breakdown here of 131, the first one here means row. Okay, the subplot grid has only one row. If you check very well, it has one row. This means this is horizontal. This is one row. Then 2 means column. This second one, this column, this number 2 means column. This 3. You have 3 columns. That's why 3 columns. You see 1, 2, 3. So I'm giving this is a structure here. This is a row. These are columns. Okay, you have 3 columns. So the second one means column, and this one means position. Position of each. So the first one is first position. Second one is second position. Third one is third position. Okay, that's why I have 1, 2, 3 here. So the places where you position each of them. Alright. So it is possible for me to now have for example, now only one row first, go to 1, okay, 3 columns, second order. So I can now, if I can double this, for example, I can double this one. Maybe I have 1, 2, 3. Then under it I have another 1, 2, 3, making 6. Right. So that automatically becomes what? If you check very well, that becomes 2 rows. Right. It means that here my this one here, okay, become 2. Okay, I'm having 2 rows now. Okay, so 2 rows. If I still want to have 3 columns, I maintain my 3 columns now. I say 3 columns, but the position now will change to 1, 2, 3, 4, 5, 6. Okay, so row wise. Okay, row wise. So it will change. So you can see that is how we plot in Python. It's very easy. So you can do multiple plotting and make them to be in one page like that. You can have 10, you can have 21 pages. You can control the positions and their rows. So that is very simple. So that is just that about that. So let's continue. I just want to have to 3D now to visualize our properly. But sometimes you may want to see both two predictors combined together in one particular chart by visualizing comparing with the target variable, which is our y-axis. So we are looking at YouTube, Facebook newspaper now combined together. So but we want to hold this one newspaper constant for now, right? You can swap them, okay? You can swap them and make it a Facebook constant or YouTube constant as case may be, depending on what you want. So this is what we want to do now. I want to show YouTube and Facebook in line with our what they call it now, our sales. So this will be our vertical axis. So you can see our plot here. So if I run this line of code now, we'll be having my 3D plots. Just hold on, I think it's loading. Alright, so now this is our face. Now we are looking at YouTube versus Facebook now. This paper at mean, which means at constant value. So look at it. This is our 3D plot, right? So we are having our sales here, okay, vertically. It's not showing properly. Something is hidden from there. Let me see if I can increase this or reduce it. Let me see, make it 14. Okay, let me see if I can make it 14. Then this one, make it this one 6. I'm trying to see if I can improve the visibility. You can see, no, that's not helping. Let me make it let me say 12 by 5. It's coming out gradually. something is hidden there. Let me make it 10 by 4. I don't want it to be too big. I want to see everything inside it completely. Can you see? Now it's out now. So though I don't, you can make it more bigger. So I want to see everything completely. So this sales, this is a Facebook budget, and this is a YouTube. So you can see it's not coming out very because it's CDD. So you can make it more bigger because I don't want to expand it too much. I want to make it very simple. So this is what we have now. Okay, this is just the plot I'm talking about. So the key insight we have here is that we see that the plane shows predicted sales at different YouTube and Facebook combinations, and the red points are actual observations, right? Some lies above and below the plane due to newspaper effects, and there also steeper slope in Facebook direction confirm its stronger marginal impact, right? Can you see? So we can also have what they call coefficient plots for them, okay, coefficient plots, and which can give us confidence interval as well. Based on our confidence interval now, which we have done before, we can run this line of code to give us coefficient plots at a 95% confidence interval. So we can see that here we have our YouTube here, we have our Facebook here, and our newspaper here. This particular plot now, the Facebook coefficient is positive and significant, which means interval doesn't cross 0. Okay, it doesn't cross 0, so it's up here. Okay, and for newspaper, interval cross 0, not statistically significant. You can see here, this 0 line that's crossed below 0 here already, so which is not supposed to be. Then YouTube has the largest absolute effect. Okay, which is this one. I mean, this YouTube. Sorry, this one does not cross 0. This is Facebook, and now this YouTube. It has largest effect. You can see here, at the top here. So you can see, you can use this coefficient plot also to explain properly our values, what we got, right? So it's as simple as that. So we can also see from here, if you want to run our this thing, you can see the model here. You can see it's just one model, okay, to explain our actual sales. Okay, this is our actual sales now for this particular plot, all right? For this one, this actual sales. So we are having multiplication versus reality now. So look at this, our actual predicted sales versus actual sales. So the points are actually close to the end red line, indicates actual accurate prediction. The tight clustering shows our model works well, right? So you can see that the model works fine. So that is just an example of a classification. I mean, visualization you can get in our what they call it now, our multiple linear regression. So I'm going to stop there for now. This part two. So I'm going to continue from the next when we look at another supervised learning, and as we journey gradually in this basic machine learning simplified class. Okay, so I'm going to see you on the next class. Thank you so much for listening. You can like, you can share, you can comment if you want, and I will see you in the next class. Thank you once again. Bye for now.